first one, they have negative 4y squared times the quantity 5y to the fourth minus 3y squared plus 2. So we are going to use distribution here. We're going to take that negative 4y squared and we're going to distribute it to each piece here. So we would say negative 4y squared times 5y to the fourth plus negative 4y squared times negative 3y squared plus negative 4y squared times 2. So we're distributing to each piece there. And so just like on your last test, for something like this first group, you would multiply your coefficients, negative 4 and positive 5, which would be negative 20. And then y squared and y to the fourth, you will add those exponents. So your new exponent would be y to the sixth. Negative 4 and negative 3 will give me a positive 12. Y squared and y squared, I'll add those exponents, y to the fourth. Negative 4 and positive 2 will give me a negative 8. Y squared doesn't have anything to combine with, so it's just y squared. So now we're doing distribution with our properties of exponents, all right? So try those A, B, and C there. So when you distribute that, you should get 20b cubed plus 4b squared plus 24b. For the second one, you're distributing negative 7h, negative 7h. So you should have gotten negative 21h cubed, positive 56h squared plus 7h. And then for the last one, you're distributing 2x. 2x cubed minus 12x squared plus 10x. Questions on those three? All right, so you have done greatest common factor, and hopefully you've done it in this setting as well. But what you're looking for here now is you're looking for a greatest common factor not only between the numbers, but also between the variables. And so basically what you want to do is you want to break it down into prime factors. If you remember prime factors from like factor trees or factor ladders or however you did factoring in middle school. All right, you're going to look at the first term, the 4x cubed. And I'm going to break that down into the smallest primes that I can do. That would be 2 times 2. And then for the variable, there's 3 of them. X times X times X, right? If I look at the 12, X squared, that's also going to be 2 times 2, which is 4, times 3. Those are all primes, and I have 2 X's. And then if I look at the 8X here, and we're only going to look at the absolute value for this guy, we'll worry about everything else later. This is 2 times 2 times 2. And then I have 1x. So those would be my prime factors. If I'm looking for the greatest common factor, I'm going to use the most of these that I can. All right. So however many I have in each one of these, I can use. So if I look at my 2's, I have 2 in the first one. Well, I did till I erased it. I have 2 in the first one, right? I also have 2 here that can be used and 2 here, all right? So all of these have 2 2's, all right? What you'll notice is I did not highlight this one because this doesn't have a third one and this doesn't have a third one, all right? So I can only use 2 of them. So I'm going to say, well, 2 and 2, those can all be used. The 2 here cannot be used because it's not in all of them. The 3 cannot be used because it is also not in all of them. For my x's, the most I can use is the least that I have. So which one has the least number of x's? The 8x, right? And how many does it have? It has 1. So the most x's I can use is just 1. So I can just use an x here. And so my greatest common factor here would be 4x. All right, now I'm not saying you have to do that every time you find this process. Obviously, I'm breaking it down for you. What you're doing is you are looking at all 3 of these numbers, all right? And you are saying the greatest common factor between 4, 8, and 12, all right? What is the biggest number that goes in all of those? Well, it's 4. 4 goes into 4, 4 goes into 12, and 4 goes into 8. And so that's how I get my 4. When I look at my variables, cubed, squared, and to the first power, I can only pull out the least because I can't pull out 3 x's from the last one. He doesn't have them to give me. And so when I look at variables, I'm going to say, well, the least that I have is just 1x. And so my greatest common factor here would be 4x, all right? And that's how they've broken it down. So when you look at these, look at the numbers first. What's the biggest number that goes into all your numbers? And then for variables, you're looking for the lowest number of variables that any one of them has. So go ahead and find the greatest common factor for those three. 3, right? The one on the right is 3. So 5v cubed would be your greatest common factor. Rayleigh, what about B? What number do 3 and 18 have in common? You're looking for division, which you can divide by. So it's going to be your 3, right? What's the least number of t's you have?
Just one. Wait, t's.
T's. 18 has how many? None. So you can only take out a 3 here. That's it. No variables can come out. If you have a number without any variables, you can't pull a variable out. All right, Preston, what about the last one? What's your number that's in common to 4, 2, and 6? And what's the least number of b's any of them have? 1, so 2b to the first power. All right, makes sense? When you are factoring, this is the first step in factoring trinomials, so you need to learn it. When you're factoring out a monomial from a trinomial, you have to first find your greatest common factor, and then you divide it out of each piece, okay? So what I'm going to do is I'm going to look between 3, 12, and 15. What is the greatest number that goes into all three of those? 3. All right? Between my x's, I have x cubed, x squared, and x. What's the least number of x's I have there? X to the first power. So my greatest common factor is 3x. 3x, all right? And then I am going to actually take that out of the trinomial. Factoring means to take it out. Distributing is to multiply it in. Factoring is to take it back out. And so when I factor, I am going to look at each piece, and I am going to divide each piece by that 3x, all right? So I'm going to look at the first one. What is 3 divided by 3? 1. So I have 1. What about my x's? I have x cubed divided by x. I have 3 x's. I took 1 out. How many x's do I have left over? 2. So that's x squared. All right. Look at the next one. Negative 12. Negative 12 divided by 3. What is negative 12 divided by 3? Negative 4. For my x's, I had 2 of them. I took 1 out. How many x's do I have? 1. For the 15, positive 15 divided by 3 is 5. I had 1 x. I took 1 out. How many do I have left? None. So this is factored. 3x times x squared minus 4x plus 5. That is factored for that trinomial. Find the greatest common factor, divide each piece by it. So go ahead and do A, B, and C. All right, for the first one, what's your greatest common factor between 8x squared and negative 12x? 4, and then for variables it is x. So we take a 4x out of both. You should have gotten 4x times the quantity 2x minus 3. For B, 5d squared and 10d. What's your greatest common factor between those? 5 and d. So you should have gotten 5d, d squared plus 2. Last one, greatest common factor between 6m cubed, 12m squared, and 24m. 6 and m, right? 6m, m squared minus 2m minus 4. Good?